Hi, this is Joe Hammond. I'm with Silexica. We're at the Xilinx Developer Forum, and I'm showing SLX for FPGA workflow today. Our example today is a Xilinx 706 board, and we're running a very simple video graphic demonstration right now. So inside SLX, we have the capability of analyzing application software, C code, and determining what makes sense in that C code to offload onto the FPGA. So if I take a look at the capabilities, so here's the call graph after we analyze the code. We do this with a mixture of static and dynamic analysis. And we can see from this that it generates a call graph that shows us where the hotspots are in the code. After looking at the hotspots, we can then determine what makes sense to offload into the FPGA. So we're integrated in with the Xilinx toolchain, and we're able to find parallelism, do hardware-software partitioning. So I can take that analysis and determine which piece stays on the CPU and which piece goes on the FPGA. So over here in this particular example, looking at the hotspot in the call graph, we're able to determine that it makes sense to take this particular routine and map it down into the FPGA. So SLX also gives us the ability to modify the pragmas as they're used. So in this case, our analysis looked at the FPGA and determined that it was able to do 630 iterations of this loop down in the FPGA. But in this case, I'm able to override that and change that down to 180. So it gives us a way of optimizing what actually gets generated that goes down into the fabric. After that is done, we can click over here and it will generate the pragmas. And if I look at the source code, I come down into here, open this up, and expand it. I can see down here that this particular function that we looked at in the hotspot generator was actually modified by the pragmas. The next step would be to click on this button. I'm not going to do it because it takes about 15 minutes to generate the code, but this would actually then complete the cycle and generate the bit stream that goes on the target. So basically SLX lets you take C code, analyze it, determine what can be parallelized, what goes down into the fabric, what stays up on the processor, and seamlessly integrated with the Xilinx SoC toolchain and Vivado toolchain, we can generate the bit stream to do offloading for FPGA.